Hi everyone, I'm Sneha and welcome back to my channel. In today's video, I'm going to talk about what you should actually learn first if you want to get into AI. If you have been learning terms like RAG, LLMs, AI agents, or generative AI everywhere, but you are thinking, where do I even start? Then this video is for you. And by end of this video, you will know exactly what to learn first and in what order. So, don't waste your time in learning random AI buzzwords. So, let's get started. Now, before we jump into RAG or AI agents, let's first understand what an LLM actually is. So, an LLM, which stands for Large Language Model, which is simply you can understand it as brain behind every AI applications or modern AI. So whenever ChatGPT writes code, Claude summarizes a document, or Gemini answers your questions, the real work is being done by an LLM. So think of it like this: RAG, AI agents, and AI engineering are like different apps, and LLM is the engine powering them all. That's exactly why I put LLM at bottom of this pyramid. Everything else like RAG, AI engineering, agentic AI, and AI agents. These all built on top of it. So, if your foundation is strong, then learning the next topics become much easier. So, what should you actually learn first? Then don't just use ChatGPT. First, learn prompt engineering because better prompts give you better results. Then understand tokens and context windows so that you know how an LLM process your information and why it sometimes forgets earlier parts of your conversation. Then the next topic you should learn about hallucination because AI can sometimes sound confident even when it's wrong. Now, after that, you should understand fine tuning versus RAG because they solve different problems, and this is a common interview question. Finally, you should learn function calling, which allows an LLM to use APIs, databases, and external tools. Now, here's something many beginners worry about: which model should I learn first? Honestly, it doesn't matter that much whether it's OpenAI, Claude, Gemini, Llama, Mistral, or DeepSeek. The concepts stay the same once you understand one LLM well. Switching to another will become easy. And don't just stop at theory. Build something like a chatbot, PDF question, answering app, a resume analyzer, or coding assistant. Because when you build projects, this will help your resume stand out. So remember this one line: master the concepts first, then models will keep changing because the concepts stay forever. And once you have got this foundation of LLM, you are ready for step 2, that is RAG. Now you have learned about LLMs. So here's question: if LLMs are already so powerful, then why do we even need RAG? So imagine you ask ChatGPT, what's the latest leave policy of my company? Then the ChatGPT probably won't know. Why? Because an LLM only knows what it learned during training. It can't magically know your private company documents, PDFs, or latest information. That's exactly where RAG comes in. RAG stands for Retrieval Augmented Generation. In simple words, you can understand it as instead of answering only from its memory, the AI first searches for the right information. The AI first searches, then generates the answer. That's why I always remember it like first it retrieve, then generate later. Now, without RAG, AI can give outdated information. It will hallucinate or completely miscompany a specific knowledge. But with using RAG, it searches your own documents, find the most relevant information, and then answers based on that context. So your response becomes more accurate, more up to date, and much more trustworthy. Now, let's understand the five building blocks of RAG. The first one is chunking. It means large documents are broken into smaller pieces that is called chunks. Why? Because searching a 300-page PDF at once is inefficient. That's why chunking comes in. Now, the second step is embeddings. In this, each chunk is converted into numbers. That is called embeddings. Think of embeddings like GPS coordinates for meaning. Instead of matching exact words, AI matches similar meanings. Now, the third point is vector database. Those embeddings which are stored inside a vector database, this makes searching incredibly fast. The further point is retrieval. Now, when you ask a question, the system finds the chunks that are most similar to your query. And finally, generation. The LLM reads those chunks and writes the final answer. Now, there are different types of RAG too. First is naive RAG, which simply retrieves information and generates an answer. But in advanced RAG, which goes one step further, like it can rewrite the query, retrieve better results, and re-rank the retrieved chunks. Also, it can generate a much higher quality response. So, there are some popular tools and technologies to start with RAG. Now you're thinking what tools you should learn first. So start with LangChain to build RAG pipelines. Then use Fash or Chroma for local vector database to store the data. Now if you are building production applications like Pinecone, if you are building production application, then learn Pinecone, or you can also learn Weaviate or Quadrant. If you are working with document indexing, then Llama Index is another great option. Now you might thinking where RAG are mainly used in real world use cases. So RAG is actually used in customer support chatbots, company knowledge assistants, legal document search, medical search, banking, insurance, and even in coding assistance. Anytime AI needs to answer using your own data, then RAG is probably involved. Now, if you really want to excel in AI, then don't just learn or watch tutorials, build something on your own. Like start building a basic projects like a PDF question answering chatbot, a website chatbot, a company knowledge assistant, or even a chatbot that answers question from multiple PDFs. These are exactly the kind of projects recruiters love to see in your resume. Now, beginners usually do these common mistakes. So, I'm explaining how you can avoid these common mistakes, like using huge chunks, poor embeddings, skipping re ranking, or trusting the LLM without evaluating their answers. This quality of your RAG system depends on things like you should use good data, good chunking, and good embeddings. So here's the biggest takeaway. LLMs give AI intelligence. RAG gives AI the right knowledge. Like without RAG, AI answers from memory, but with RAG, it answers from your data. That's what makes modern AI applications truly helpful. Now, so far, we have learned about LLMs and how RAG helps AI use external knowledge. But here's the question, how do companies actually turn all of this into products used by millions of people? That's where ML engineering comes in. Think of it this way, a data scientist builds a model, then an ML engineer makes sure that model actually works in real world. Machine learning engineering isn't just about training models. Instead, it's about building reliable AI system that can be deployed, monitored, updated and scaled. Because building a model in Jupyter Notebook is one thing, but running it for millions of users 24/7 is a completely different challenge. Now, why ML engineering matters? Imagine Netflix recommending movies, Amazon suggesting you products, Google detecting spam, or your bank detecting fraud. Behind all these applications is ML engineering. Its job is to make AI systems fast, reliable, scalable, and always available. Now, let's see how an ML project actually works. It starts with understanding the problem. For example, can we predict whether a transaction is fraudulent or not? Next, we collect the data from databases, APIs, or user activity. Then we clean and prepare the data because messy data can lead to poor prediction. After that, we train and evaluate the model until it performs well. Once the model is ready, we deploy it as an API or service so applications can use it. But the work doesn't stop there. We monitor the model continuously because user behavior changes over time. And if accuracy starts dropping, we retrain the model with fresh data. That's why ML engineering is a continuous cycle, not a one time task. Now, you must be thinking, what tools should you learn for this? So, start with Python language because it's the most popular, simplest language for machine learning. Then, learn scikit-learn for classical ML algorithms and PyTorch or TensorFlow for deep learning. Now understand ML flow for experiment tracking. For this, you can use Kafka or Spark if you are working with large scale data pipelines. And finally, learn cloud platforms like AWS or Google Cloud because most production AI systems run there only. Now look at this ML architecture. Data flows into pipelines, then gets stored. Features are prepared and the model is trained, then registered, and the process happened like deployed and finally used by real users. So, throughout the process, everything must be monitored because if model starts making bad predictions, you need to know immediately. Now, there are some challenges in ML engineering. This is also where many beginners struggle. Like they focus only on model accuracy, but in real companies, you also need to handle poor quality data, data drift, system failures, high traffic, and security. So, building the model is only part of the job, but keeping it reliable is what companies actually pay for. So, always remember these best practices. First, validate your data, version your code and models, then automate testing and monitor everything so that it continuously improve your system. Now, if you want to build a strong portfolio, then don't just stop with simple notebooks. Build projects like fraud detection system, recommendation engine, customer churn prediction model, or an end-to-end ML dashboard. Because these projects show recruiters that you understand the complete life cycle of machine learning. Now, if you are preparing for interviews, focus on these topics. Those are data pipelines, model deployment, monitoring, feature stores, scalability, and MLOps. Because these questions appear much more often than people expect. So, here's the one sentence I want you to remember that data scientists build models, but ML engineers build products with those models. That's the difference. And once you understand how to build production ready AI systems, then the next steps will be AI engineering. Now comes the exciting part, that is AI engineering. This is where everything you have learned finally comes together. So, what exactly AI engineering is? Think about ChatGPT. Someone had to connect the LLM, retrieve information using RAG, build the backend, connect APIs, design the user experience, and then deploy it. And make sure millions of people can use it every day. That's what an AI engineer does. An AI engineer doesn't just build models, instead, they build complete AI products. A lot of people ask me, like, what's the difference between AI engineer and ML engineer? So, here's the easiest way to remember it. Like, an ML engineer focuses on training, improving, and deploying machine learning models. But AI engineer takes those models and combines them with LLM, RAG, API, databases, and user interfaces to build real application. So, in simple words, you can understand it as ML engineers build the engine and AI engineers build the entire car. Now, let's see how an AI application is actually built. So, first understand the user's problem, then collect the right data and tools. Next, decide which approach fits best. Like, do you need only an LLM? Do you need RAG? Or do you need AI agents? Now, once you have made that decision, then you build the application, test everything, deploy it, and then monitor how people will use it and continuously improve it so that building AI will not become complex because it is not a one time task, it's an ongoing cycle. Now, this is probably the most important part of the slide. Like, an AI application isn't made from just one technology. Like, you can combine LLM, RAG, APIs, external tools, and sometimes AI agents also. Like, when these pieces work together, you get applications like ChatGPT or GitHub Copilot. It can be Perplexity also, or AI customer support assistance. Now, what tools should you actually learn for this? Like for LLMs, start with OpenAI, Claude, or Llama. For orchestration, you should use Learn LangChain or Llama Index. For vector databases, you can use Pinecone, Waveat, or ChromaDB, which are great choices. For APIs, Fast API is one of the most popular frameworks, and Docker will also help you package and deploy your application consistently. Now, to become an AI engineer, you don't just focus on prompting. Instead, you should also need Python, API development, system design, RAG, vector databases, cloud deployment, and the ability to evaluate AI systems. So, the strongest AI engineer understand both software engineering and AI. Now, where AI engineering actually need? Like, it is useful to make chatbots, coding assistants, document search, content generation, customer support, healthcare, banking, insurance, and etc. Almost every modern AI product you see today built with AI engineer. Now, if you are building a portfolio, don't stop with basic building up demos only. Because start building a PDF chatbots so that you will gain practical experience. Start creating an AI coding assistant, build YouTube video summarizer, or create an AI agent that automates your repetitive tasks. Like these are the kinds of projects recruiters love because they solve real world problems. But building AI isn't always easy. You will deal with hallucinations, API cost, sometimes latency, security, and making sure your AI gives reliable answers. That's why testing and monitoring are just as important as building AI application. So if you are wondering what to learn next, then follow this order. Like start with learning Python, then machine learning basics, then LLMs, RAG, APIs, started building projects, and then learn deployment and system design. You can deploy it through Streamlit and all. And don't try to master everything at once. Build one project at a time so that you gain confidence. Now, here's the one line I want you to remember. Like LLMs give your application intelligence, but RAGs give it knowledge. And ML engineering makes model reliable, and AI engineering combines everything into a product so that people can actually use it. And once you have mastered this, you are ready for the future of AI. that is AI agents. Now, let's take one more step forward with topic Agentic AI. This is where AI stops just answering questions and starts thinking, planning, and taking actions. So, what exactly is agentic AI? Imagine you ask a ChatGPT, plan my 5-day trip to Japan. A normal chatbot might give you an itinerary, but an agentic AI goes much further. It can search for flights, compare hotel prices, check the weather, book restaurants, and update your calendar. Even it can change the plan if your flight gets delayed. So that's the difference. A chatbot answers or AI agent acts. Now, why do we need agentic AI? Because many real world problems aren't solved in just one step, like booking a vacation, researching on a topic, building software, or managing customer support, all require multiple decisions and actions. Instead of waiting for you to tell it every single step, an agent can figure out the next step on its own. Now let's understand how an AI agent actually works. Think of it as a loop. First, it perceives the situation by collecting information. Then, it reasons about what needs to be done. Next, it creates a plan and breaks a big goal into a smaller task. After that, it acts using tools like APIs, databases, or web searches. Then, it observes the result, like did the action work? If not, it adjusts the plan. Finally, it reflects on what happened and learns from the experiences. Then, this cycle repeats until the goal is achieved. That's what makes agentic AI feel much more intelligent than a traditional chatbot. So, what makes an agentic AI or what makes an AI agent different? As it has a goal, plan, or it has memory, it can use tools, or it can adapt when something changes. Also, it can continuously learn from feedback. Now, look at this architecture. A user gives the agent a tool, a goal. The agent understands the request and it uses an LLM for reasoning, like it creates a plan or it calls an external tools or APIs. It stores useful information in memory and finally it returns the result. Like everything works together as one intelligent system. Now, for the working of agentic AI, what framework should you learn? So, start with LangGraph if you want to build a structured agent workflows. Learn Crew AI for multi agent collaboration and explore AutoGen for autonomous AI conversations. If you are already using LangChain, then moving to LangGraph becomes much easier. Now, an agent isn't limited to generating text, like it can search the web, run Python code, call APIs, your query databases, it can read files, and even communicate through tools like Slack or email. That's what makes it useful in the real world. Now, another powerful feature is memory. Like agents can remember previous conversations, it can store important information and use that knowledge in future tasks. Like it combined with planning strategies, like react and plan and execute, so that they can solve much more complex problem than a simple chatbot. Now, where is agentic AI being used today? In real world use cases. So it's used in So, we have finally reached the end of our AI roadmap journey. Now, let's quickly connect everything we learned. We have started with LLMs, that is, the brain behind modern AI. Then, we learned RAG, which gives AI access to your own knowledge instead of relying only on what it learned during training. After that came ML engineering, where we learned how to build, deploy, and maintain machine learning systems in the real world. Then we moved to AI engineering, where all these technologies come together to build real AI products that people actually use. And finally, Agentic AI, where AI doesn't just answer questions, instead, it can reason, plan, use tools, and complete tasks on its own. Now, here's the important message I want you to remember. Just don't try to learn everything at once. Pick one topic, understand it well, build one real project, then move to next step. Because that's how real AI engineers grow. Now, by watching hundreds of tutorials and you are started building, there's a difference. So remember, AI isn't about collecting certifications or it's about just watching tutorials. You will go in hell. It's about solving real problems. So stay curious and keep building and keep improving. And don't be afraid to make mistakes, since every project you build teaches you something new. So, if this roadmap made AI a little less confusing, then save this video, share with your peers, or you can come back to it later. If you know someone who is feeling overwhelmed about where to start, then share this with them. Thank you for watching, and I'll see you in the next video.